Hi, welcome to the podcast of Data and Analytics in Business. We'll learn from the leading industry experts using data and analytics to solve the problems and create values in practice. We'll also learn where the industry is heading to and how data and analytics will shape the industry in the future. Most importantly, how they are preparing their business for digital transformation and disruption in the future. I'm your host, Jason Tan, and thank you for listening.
So thank you for coming to my podcast. Today we have Damian Morris. So Damian Morris was the CIO of Queensland Motorway, which is now known as the Transurban. It managed about 70 kilometers of long of toll roads in Brisbane. So some of its assets included Clem Jones Tunnel or Gateway Motorway. So prior to this, Damian was the CEO for a company called Transtoll. They developed and maintained the end-to-end tolling system. Damian, he now runs a consulting company. He works with the legal and commercial teams to negotiate, maintain contract suit for design and delivery of complex systems into large infrastructure projects and project delivery teams to help manage and govern their project programs. So I'm really excited to talking about this because how to use the data and analytics, and also how the digital transformation and the digital disruption is coming to this whole road network system, and also the transport industry as a whole.
Fantastic, thank you, Jason. I'm very excited to be here. It's my first podcast, so please go easy on me.
I'm sure you will do fine. So, do you want to give us a bit of background in terms of like what you do for your current consulting company? If someone was going to ask you the service that you provide for your consulting company.
Sure, absolutely. So first thing, I'll just note just one minor clarification. So I was, as you point out, CEO for Queensland Motorways, and this was the period before it was sold to Transurban, and it's now part of Transurban, known as Transurban Queensland. So what I do through my company, Moso Consulting, is that I work with, I essentially deliver three different kinds of services to my clients. So I work with legal and commercial teams, as you say, to particularly to negotiate, design and construct contracts and operate and maintain contracts for the delivery of systems and the integration of systems into infrastructure projects. So traditionally big, large civil engineering focused projects, and delivering systems into those projects is an entirely different engineering discipline. So my background is firstly as a software engineer, and I just happen to have worked inside of these large infrastructure projects for the last 10 or even more years, and I've become quite familiar with the differences in emphasis and focus between civil engineers and systems engineers, and they're fundamentally different disciplines, which was something that surprised me enormously when I first encountered it. The second thing I do is I work with project delivery teams. So I've managed substantial programs of systems integration projects. And so I have a very delivery-oriented sort of focus, although I have a technical background as a software engineer. My experience delivering projects means that my first focus is always on risk and opportunity. What is going to help me deliver the project on time, or help my team or the team that I'm working with deliver a project on time, and what's going to put that at risk. And then thirdly, I work with systems engineering teams delivering systems projects as a software and systems specialist. And so I, relatively unusually in the people I work with, I work across all three of those quite separate realms. So I quite often work with project people who have systems engineering background, but they generally don't have a commercial background. I quite often work with commercial and legal teams who might have worked very closely with the teams that deliver projects, but they don't have a technical background in the systems engineering field. And so I'm able to work across all three of those areas, bringing together legal and commercial risk and opportunity, with project delivery risk and opportunity, with what it actually takes to put a solution together that will get the job done.
Wow, that is quite a bit of handful in terms of like, I suppose having been able to navigate that system engineering versus the legal and then versus the infrastructure is quite tricky, then that you often will have to put on different hats. How do you juggle on wearing different hats when you are talking to those different people? And what do you think is the key skill set that one should be developing to be able to do that and that sort of delivery when they are dealing with different people from different backgrounds?
Look, that's a really great question. And what I find that the experienced and capable people working in each of those three fields all share is that they focus on risk and they focus on reward. And so what I do is I help people in each of those three fields identify and prioritize where are my risks and what are my objectives. So first and foremost, I often find that people are involved often for quite a long time and give a great deal of thought to working on projects where it's easy to lose track of what your objectives are. So one of the first things I always do is I ask everyone in the room, what are you trying to achieve? What are you trying to achieve? What are you here for? So ultimately, everything comes down to identifying who are the stakeholders that have a stake in the outcome of what it is we're trying to do, what will make them happy, what keeps them up at night. And often we find that whether they come from the legal and commercial background or the project delivery background or the systems engineering background, the people able to look at the big picture share a common view. They focus on what is it I'm trying to achieve, what are the things that I know could put that at risk, what are the things that I haven't yet identified that I don't yet know about. So if I can manage and mitigate the risks presented to my objectives, I can then focus on developing the best way to try and achieve my objectives. And the other thing I can do is I can monitor it and report on my progress towards achieving those objectives. So all of those people tend to have a clear outcome in mind, or at least they've identified that the first thing they need to do is know what they're trying to achieve. And the second thing they need to do is identify what could put that at risk.
Right. So in terms of the system and the digital technology, so for those of us who are not familiar with the road network system, and for those who are not necessarily in the transport system, what are the typical digital system or the IT system being used or being deployed at the road network system?
So there's a quite substantial industry that supports the delivery of efficient road network. And by that, sorry, I should say, not the delivery, the operation of an efficient road network. So it's known in the industry as ITS, as Intelligent Transport Systems. And a key part of any modern road system, whether it's a piece of motorway or it's the road network as a whole, is its ability to deploy ITS to get the most efficiency out of the physical asset, the road itself. And so a well and substantially delivered ITS system can add anywhere between 10 and 25% of efficiency to the existing physical asset without any change or upgrade in the actual physical asset. So no addition of lanes, no straightening of the road, the active management of the utilization of the road through the deployment of ITS can substantially improve the efficiency of it by motorists every single day. And so as you can imagine, there's an enormously effective bang for your buck considering the cost of road infrastructure and the cost to change road infrastructure once it's been deployed. And so throughout the world, and Australia is at the forefront of this, there is an extremely active and ongoing deployment of ITS into the existing road infrastructure network, as well as all new road infrastructure. And that's being deployed pretty much every day across all of our cities. You see digital speed limit signs, for example, You see digital message signs informing motorists of the current status of the road, current status of congestion, whether there's an incident ahead, whether there's a football game at a nearby stadium causing traffic delays, what the current travel times are to popular destinations and so on. And through and what you don't necessarily see is deployed into the road are all kinds of sensors, whether they're camera for video detection of not just road usage but incidents, breakdowns, accidents and so on, unusual events, safety critical events, but also the utilization, how much traffic's on the road, how well it's flowing, what speed it's flowing at and so on, so that the active management of the road by traffic management centers, they can then adjust the operating parameters, if you like, of the road and change the speed limits to manage congestion across the broader road network.
Right, so it is the installation of all of those camera and also the sensor where it actively and continuously collect all the data, and then it feed back to the headquarter or feeding it back to the system, and then doing the real-time feedback in terms of like if there is an incident at the front, then it will subsequently adjusting the speed limit and also informing the traffic about all these issues.
Absolutely, yeah, absolutely. And there's a number of different tools that are actively used, and as you say, they're used in real time, many of which are automated first of all, to model the usage of the road network, so identify what's an efficient set of operating parameters, to model potential scenarios where incidents happen, where there's congestion, where some traffic lights have gone out, for example, whether there's been a breakdown and so on, and then to model what's the best response to keep the road safe and operating at the most efficient parameters.
So while we are on this topic, one of the really interesting things that I think probably will be coming out from the future is the connected and automated vehicle. So by what I mean is like the self-driving car by Tesla, Google, etc. And a lot of time what this automated vehicle is like, they will have the camera or the LiDAR system that is constantly scanning the surrounding area and then processing with the system on the car. I'm curious to know, do you think that is a possibility that the ITS on the road network system, i.e. those camera, etc., is able to share the workload of the automated vehicle? So they will be talking to each other and then subsequently improve the efficiency in terms of the automated vehicle on the road.
Absolutely. So the branch of ITS that relates to exactly what you just described is known as CITS, the C being for cooperative ITS. And so there's a couple of different ways that happens. One is known as vehicle to infrastructure, so that's where the vehicle talks to the road. So for example, the operating system of the road that's detected that there's an incident around a bend, for example, can inform the vehicles that as they're approaching, they can automatically start to slow down, obviously thus improving safety and reducing the risk of accidents as motorists come around the corner and unexpectedly see an accident. If their infrastructure has already detected it, spoken to their vehicle, over CITS, their vehicle has automatically slowed the speed of the vehicle, and generally the safety of the overall road network is improved. The other aspect of it is around vehicle to vehicle. So the first one we call vehicle to infrastructure, V2I. Second one's around vehicle to vehicle, where my car's, I'm traveling behind your car down the motorway, for example, and my car's constantly talking to your car and saying, I'm 25 meters behind you, I'm 20 meters behind you, I'm 15 meters behind you. And the car in front saying, whoa, slow down, my motorist has just put his brakes on. You need to react accordingly, and in extreme circumstances, you can imagine my vehicle automatically applying its brakes and so on. And so that's vehicle to vehicle, V to V. Together, these are known as V to X, so vehicle to X being infrastructure or other vehicle, and collectively known as cooperative ITS. The second area, you spoke about was around the vehicle being autonomous on its own without necessarily direct reference to other systems, but only to the environment that it's driving in and around. And these are two effectively different ways to tackle many of the same problems, and they're both happening in parallel, and we're seeing enormous amounts of progress in both fields. Cooperative ITS has been a long time goal of the ITS industry, which isn't new at all. But what we now have is we have enough rollout of bandwidth across motorways, we have enough cheap processing capacity, whether it's in the vehicles, whether it's in the infrastructure, whether it's potentially off-site from the infrastructure itself. We have high resolution video cameras that are cheap and other high capacity commodity sensors and operating equipment that make it possible to roll out this kind of capability at scale.
Wow, that is really interesting, because I thought that in terms of the technology, we are still quite far away, especially it is not something that we are often seeing on the road, apart from my experience in Japan when I was driving this the rental car that I was renting in Hokkaido. And what I noticed that it has that sensor, and then when we put that in the self driving, in terms of the speed driving on the highway, it does slow down as it detects the vehicle at the front. And to some extent, I still think that this technology is far away. But based on what you were saying, it looks like this thing has been going on for actually quite a long time. Even within Australia, is not something that only in the last 5 or 6 years that is actively happening in Silicon Valley then.
You're absolutely right. It's been going on and a lot of work's been done on this over quite an extended period of time. And Japan is actually the, if you like, the poster child for where this has been done the most extensively, and it's the most advanced. And as is often the case, the challenge here is twofold. There's technology, and there's the availability of the necessary sort of commodity bandwidth and capacity to make this all happen. But the other thing that, if anything, is a far bigger challenge, as it frequently is in systems engineering and systems integration, is around agreeing a set of standards that all of the industry, whether they be vendors, whether they be operators, whether they be the other firms and businesses that help make these things happen, can sign up to and can agree on, that has sufficient economies of scale throughout the world to spur the development and the necessary research and development of products that can make this a cost-effective sort of a thing. As is not unusual, we saw this with the advanced mobile phone industry in Japan 20 plus years ago. They were able to go their own way, create their own set of standards, which they then rolled out. And this sort of cooperative ITS has been in Japan for a really long time. The challenge for the rest of the world has been around agreeing a set of standards. And in fact, that's still, to be perfectly honest, the challenge that faces the cooperative ITS industry around the world, is around agreeing the necessary standards for different devices from different manufacturers, achieving different particular roles in this ecosystem to be able to communicate with each other. And certainly without communicating with each other, the entire premise falls apart.
So I think that brings me to the question that I'm going to ask in terms of the connectivity. While we are on that, I think what people may or may not realize is that a lot of those VTI or VTV or the automated vehicle, it needs to be able to collect a huge amount of the data, and also to be able to process huge amount of the data in almost near real time or real time capacity. And what I mean is the connectivity, the network connectivity is going to be extremely important if we want to be making this happen. And sadly, Australia is probably not doing so well in terms of the network connectivity in the developed world, and especially with what is going on in the 5G battle now about the US versus the China, etc. Let's set aside the political issue. do you think that is going to be the showstopper for us in Australia about that whole 5G connectivity in order for us to be able to move forward and move faster and also to be pioneer in this whole VTI, VTS, VTP and the automated vehicle and all the sort of things?
It is one of those areas where you need all of the pieces of the ecosystem to exist before it can be practically possible. So there's things that you can achieve in a controlled environment with a small number of vehicles that just don't make any sense, any economic or practical outcome-based sense at scale, unless you have all of the necessary infrastructure pieces. That said, you can't wait for all of the infrastructure pieces to exist, or else you're just deferring the point at which you start, and now you're 5 years behind or you're 10 years behind. And it's also extremely encouraging to see that that around Australia, an enormous amount of work's being done on cooperative and autonomous vehicles. So here in Brisbane, the Department of Transport and Main Roads is conducting a series of CAV trials that are quite ambitious and that are pushing forward what's possible in Australia. Similar sorts of trials on happily overlapping but not exactly the same areas of focus are being done, particularly in South Australia, particularly in Victoria as well. And so all our various sort of industry players are shouldering a little bit of the load. They're doing bits of the work, they're sharing what they're finding with each other, and they collectively help push the industry forward. And this is happening throughout the world. Lots of other governments that are similar to Australia. They're not particularly huge markets, but they are picking up a little bit of the slack, and together we're pushing all of these, what is possible, forward. That said, when you are a country like Australia, ultimately we tend to be, for good reasons, we tend to be market takers, not market makers. So we can help push forward what we know about what it will take to make these things work. But when it comes to developing products at an economically effective scale, when it comes to ensuring that the various products and technologies talk a common language to each other, we have established industry standard protocols and rules of operation and so on, where we contribute significantly, but we certainly can't do it on our own. And ultimately, we need there to be a strong ecosystem of these sorts of products and technologies that exist outside of Australia, as well as some of the key Australian firms that are helping to contribute to that.
Wow, interesting. That's interesting. That's really, really interesting. I think because a lot of those things clearly is outside of my main domain expertise, and then at the same time, is a lot of is those things that I don't really come across with in terms of doing the data analytics for the finance industry. If there is one thing that other industry can learn from the ITS in terms of the data analytics and the digital disruption and digital transformation, what do you think is the key takeaway that other industry can learn from the ITS and the road network system for the application and the utilization and the take-up of the technology?
I think one of the encouraging things for me is exactly that although there isn't any central organising body saying, now you work on this piece of the puzzle, you work on this piece of the puzzle, you work on that piece of the puzzle, which doesn't scale anyway, and certainly doesn't scale to a global level. We have effectively got a great mix of public and private organisations. One of the leading organisations pushing some of these technologies forward, conducting public trials, publishing some of their results, for example, is Transurban. So Transurban is a large private motorway operator. They're in fact the largest private motorway operator in the world. And many would be familiar with them. Many of us drive on Transurban's toll roads every day. And so whether it's, as I say, the Department of Transport and Main Roads here, whether it's Vic Roads in Victoria, whether it's Transurban, whether it's some of the other industry bodies, ITS Australia is a very active industry representative and lobby group that helps organise the necessary conferences, the necessary publishing of papers, the necessary study tours and so on, to help keep the different pieces of the industry working on this together and informed of what everybody's doing, and learning from everybody. So I think that this is one area where the industry is self-organizing, and we're seeing real benefits now, and we can see it's extremely exciting as to what the possibilities are for the future.
I want to talk about the tolling system, and part of the reason I want to talk about that because I see that tolling system is one of your domain expertise. Like you have delivered a lot of tolling system as part of your works at the Queensland Motorway and Transtow. Can you tell us a little bit more about in terms of the tolling system that we have got now as compared to what they have in overseas, like the States or Europe, and where we are in terms of the advance of the technology, how well we are compared to other countries?
So I think we have one big advantage that the rest of the world is still catching up on, and we also share something in common with the rest of the world, which is that it's a strong and healthy industry with a really substantial history of technical development. So one of the companies that I've worked with that you didn't mention just now was a company called Capture Trafficon, which is an Austrian company who's a leader in the delivery of tolling systems around the world, and in particularly in Australia. And so we have a strong and sort of vibrant industry of vendors delivering capable tolling systems. We benefit as much as anybody from the delivery of high capability commodity IT infrastructure, servers, storage, data, and so on. And so what a modern tolling system can do on commodity hardware, used to require quite expensive and specialized hardware. Where we do benefit in a way that the rest of the world is still really only catching up to, again, comes back to that point I sort of touched on earlier, that systems integration, often the hardest challenge is not technical. It's about bringing the stakeholders together, identifying some common outcomes, and working together to deliver those common outcomes. And what the tolling industry did here in Australia 20 years ago, that the rest of the world's still catching up to, is that they got together as an industry and they settled on some standard protocols for the exchange of information, and they settled on some standard protocols for the interface of technical devices. So particularly the e-tag that sits on your windshield in your car. When tolling was first, or electronic tolling was first deployed into Australia, and as it is true for everywhere else in the world, all of the vendors had their own e-tag, which were incompatible with each other. And so as tolling started to get rolled out to pay for some motorways across Sydney, Sydney motorists started to get used to the extremely inconvenient and quite expensive fact that they were needing to have 1, 2, 3 or even more different e-tags on their windscreen of their car just to get around their own town. And what the tolling industry in Australia got together, what some of the wiser, more experienced heads did, was say, well, that's not good for anyone unless you happen to sell e-tags. So let's get together as an industry, settle on some standards, mandate that anyone who wants to sell technology systems into the Australian tolling industry has to comply with these existing standards. And then the e-tag that you use on the M4 motorway in Sydney will work on the Lane Cove Tunnel in Sydney, or on Melbourne City Link, or on the Gateway motorway in Brisbane. And what's more, we want to make sure that the motorist doesn't have to do anything for that to work. You can take your e-tag that, you live in Sydney, you've got an account with the M5, for example, and you drive up to Brisbane. You should be able to drive down the Gateway motorway and have your e-tag not just recognised, but that the charges will be sent back to your account at the M5 in Sydney, and you shouldn't have to do anything about it. That's not a technical problem. That's easy to solve technically. And that's exactly what they did. And so in Australia, for probably nearly 20 years, you've been able to have an account with any of the toll road operators, and those have changed substantially over time. And you can use any toll road in Australia, and you don't have to do anything to make that happen. The tolling industry organised itself, or I should say the road operation industry, organised itself, told the tolling industry these are the standards you must comply with to be able to sell a tolling system into Australia. And they removed all of the extra work and the overhead from motorists.
Yeah, I do notice that, especially when I travel to other country or perhaps Malaysia, is that I do notice that there are multiple tag that people need to have on their vehicle. So how does it work in terms of that system itself? Like, do you have one centralized system where it basically do the what I call perhaps the clearinghouse, that it charge all these different user and then it charge it back to the toll company? How does it work?
So having a central clearinghouse is a way that is done in some parts of the world. The way that it's done here is a little differently. There's a technical clearinghouse. So at the end of the day, each motorway will take all of the transactions that's detected for customers that don't that aren't a customer of theirs directly, that are a customer of some other motorway. It will send them to a central clearinghouse that's operated by the Roads and Maritime Services in New South Wales. So the New South Wales Road Management Agency, public agency. And then that each motorway will poll that gateway for any interchange files that are destined for it and pull them off, process them all internally, and then update the accounts of all of their customers accordingly. So to make this happen, each of the motorways have what's known as a roaming agreement. So they have a commercial agreement with each other motorway in Australia. And in fact, in order to operate a toll road in Australia, you need to have set up such an agreement with each of the other motorways in Australia so that you can have this, I was going to say we call it interoperability. That's only because the English word for it is on interoperability. And so the onus has been placed on the industry to make all of this work. But there isn't a central clearinghouse for financial transactions per se, only for data.
Right, I see. So to some extent in the finance industry, it almost looks like the central bank, the RBA, where they act like a central clearinghouse to all the different banks, and then it just operate that override.
Exactly. In some other locations, that's what they do. What we do here is just the exchange of data. Now, we have one enormous benefit that many other jurisdictions don't have, which is that we are a single nation bounded only by water. Whereas when you have a common land border with another nation, your big challenge then is if you happen to be in Malaysia, for example, and someone from Singapore drives into Malaysia, drives through your motorway and goes back into Singapore,
correct.
Your big challenge is how do I collect that debt if they don't want to pay?
Yeah.
We don't have that challenge in Australia. All of the state governments that legislate the legislative framework that supports the enforcement of tolling debts permit the collection of debts whether you happen to cross state boundaries or not. That's a much more complicated challenge when you're crossing national boundaries.
Right. So Australia being so far away from the rest of the world is a blessing of itself in this particular example.
If you happen to be a road operator that charges for access to your road, absolutely.
Right. That's interesting. That's cool. That's good. So I want to move into talking a little bit more about analytics. We have been talking about the data collection and what sort of data being collected through various topics. In terms of analytics, in your experience, what sort of analytics has been being applied in the transport industry and the road network system?
So there's a number of different ways to do it. So the reason that you build and operate a road is to provide a number of things to motorists, people who want to get from A to B. They need to be able to do it safely. First and foremost, it needs to be safe. So a huge part of the focus of operating a piece of road infrastructure is how to make it the safest possible piece service for motorists to use. Second, obviously, is also about being efficient. We need to get as many people from wherever they're coming from to wherever they want to go as we possibly can, get the best bang for a very substantial infrastructure buck. And thirdly, what's quite important to people isn't just getting there as efficiently and safely as possible, but it's getting there reliably so that they can reasonably reliably estimate how long it's going to take to get from where they're coming from to where they need to go to. And so that's really the sort of third primary focus of the operation of a motorway. And the third primary focus on the analysis of the quite substantial amounts of data that are collected from a motorway is how do we make sure that we keep the traffic moving and that we are providing constant feedback to motorists so that they can plan their routes accordingly. It's in everybody's benefit if there's a congestion on part of the network, regardless of whether that's caused by an accident or whether it's simply caused by too much traffic trying to use that part of the network at any given time, that we inform the rest of the network to try and take alternate routes if they possibly can. And so the amount of data that's collected has a couple of different values. The first one is that can we use it in real time to make the actual current right now usage of the motorway as safe as possible, as efficient as possible, and as reliable as possible. And then the second thing is what can we use that data to do when we have a little bit more time to improve all of those sorts of things, whether it's the collection of the costs, the tracking of the costs to operate it, the collection of the revenue necessary to operate it, whether it's the modelling of seeing how the usage of the motorway changes over time as new suburbs are developed, as shopping centres go up, as new hospitals go up, as new schools go up, as higher density housing goes up, and people's need to use road transport changes over time, because it's an extremely dynamic thing.
Wow. Okay, cool. So it really also, as those data are collected and apply the modeling, etc. But the other picture is about also the urban planning. So that is working with the state government to help them to understand how to plan the city, and using the data that the network road network operator is collecting. Is that some sort of the active conversation that is going between the state government or the federal government with all of these road network operators?
It's extraordinarily valuable data for us, and in fact it's so valuable that in the recent privatisation of the WestConnect's motorway network in New South Wales, our largest private road transport operator, Transurban, was required by the ACCC to share patronage data because they were concerned that Transurban not get an unfair advantage from the amount of data it is already able to collect from its quite extensive network, such that it can identify future infrastructure opportunities. It has an unfair advantage potentially in identifying future infrastructure opportunities. As I say, the ACCC required that they commit to sharing some of their patronage data so that other potential future infrastructure builders and operators have the same ability to identify future areas of development and of benefit and make proposals to the necessary state bodies.
So speaking of that data collection, one of the things that I see Google and Apple have the tremendous advantages is that they have all of these mobile devices on the road, and technically they can, as long as the user are providing the consent for them to collect the GPS data, they have tremendous advantage of collecting this data, and then they pretty much can know. That's why when we are using the Google Map or the Apple Map, we can see like in almost real time or in real time that what is the congestion of the road far ahead of the journey. Do you think it would be an advantage for the road operator to get access of those data? Do you think that is possible, that ACCC have the same mandate that these technology company from overseas that would now have to share those data?
That's a really interesting question. I think the first question you'd have to ask is whether one of them has enough complete data to be able to make a reliable determination as to the amount of patronage on a particular piece of motorway. So what they can identify, of course, is a relative amount of patronage, and also based on the updates over time from each of those devices, what congestion must be present on the road because the devices are now moving more slowly than the posted speed limit. What they can't necessarily identify is the actual patronage, and they can't potentially identify, well, I suppose they can apply some analytics, which, since we're talking about analytics, to try and identify that these three signals, for example, appear to be travelling in the same vehicle. Because bearing in mind that the way patronage is remunerated on a motorway isn't based on the number of users per se, it's based on the number of and type of vehicles. And so, look, we potentially will get to a point at some point where Apple and or Google will have an unfair advantage about calculating the amount of patronage on a motorway in terms that relate to effectively the value of that motorway. How much money can be collected from patrons of the motorway, thereby providing a critical input into a business case for building new motorways. Certainly at the moment, our motorway operators have sensors in the road, sensors above the road, such as the CCTV devices we mentioned earlier, whereby they can get much more useful data than perhaps either Google or Apple can. One thing to bear in mind is that different classes of vehicle are charged at quite substantially different rates. So a commercial vehicle, for example, is generally worth 2 or even 3 times the value of a private motor car. And so knowing, for example, that this particular Google Maps user is in a truck would be potentially useful when it comes to calculating the value, if you like, of the motorway, as opposed to in a motor car.
So privacy is obviously an important issue, right? We are all concerned with that. But if we just pretend it is not an issue for just 1 second, what is one data that you think that you want to collect and it will make a huge difference and you don't have to worry about the privacy?
I have to admit I've never given a thought to that, partly because, as you say, privacy is a really critical issue. And bearing in mind that these are all essentially public assets that are leased to private operators in return for payments. As you can imagine, they come with extremely strict privacy obligations. So, to be perfectly honest, it's never occurred to me to look at those privacy obligations and wonder if this was restricted, we could do this. Partly because I don't ever see them being restricted. I think, if anything, as we as society become far more aware of the implications of a lack of privacy, we're going to be, I certainly hope, far more discerning about demanding some of our privacy back, hopefully quite a lot of it. And I really haven't given any thought to what I could what evil machinations I could potentially achieve if they were restricted. They're certainly, in our industry, it is a primary concern at all times, and it does impact the way that we're allowed to operate and thus the way that we do operate.
Do you think we're gonna eventually have a system, all those camera, not only they are operating in a way that to understand the traffic on the road to help maintaining the operation and the running of the road network system, but do you think we will be moving, in particular in Australia, that we will be moving into a situation where we'll be using some of those camera in the facial recognition to help the federal government, or especially the police, to be capturing the criminal, etc., etc.
In terms of facial recognition, not without changing legislation. So one of the privacy restrictions that I just mentioned, I just was referring to, was that it must not be possible for those cameras to be able to be used to identify people. So, for example, when a tolling system takes a picture of a vehicle so that the toll can be proven against it, certainly in New South Wales, in Queensland, and I think also in Victoria, that tolling system must ensure that the passengers cannot be identified.
Wow.
And so we literally put a black square over part of the vehicle so that you have no chance of identifying the motorists in question.
Yeah.
And there are all sorts of other restrictions on trying to make sure that there are no other personally identifying items beyond what is absolutely necessary, which is generally a license plate and registration. And that's necessary, obviously, to be able to identify who owns the if you like, the debt for paying for that toll for that vehicle. But no, you will not be able to use those cameras to identify people, not without changing the legislation. And I'm very grateful for that, frankly. I think that's absolutely the right way.
What do you think is the challenge for the future for the ITS intelligent system for the road network?
Well, so as I say, really, there's a bunch of really interesting technical problems around what can we do with more data. How can we make the road network safer? How can we make it more efficient, so fit more vehicles on at any given time? And how can we make it effectively higher speed? How can we push more vehicles through in the same space of time? I'm terribly sorry. Can you say the question?
What is the biggest challenge for
What's
the
the biggest
future?
challenge? So actually the biggest challenge in lots of ways, as I mentioned earlier, is a stakeholder management one. It's around agreeing to a common set of objectives, a common prioritization. Which of those objectives are we going to focus on first? What are the protocols that we're all going to talk? Bearing in mind, we all have slightly different objectives. We want different things in the protocols. Excuse me. The other challenge is the super interesting one, and this is, what are we going to be able to do with our cities that we couldn't do before, but we will be able to do in the future once we have truly high-speed commodity road networks? What are automated vehicles going to mean for our ability to change how we design our cities? What does a smart city truly mean? And those are genuinely transformational questions. It's really incredibly interesting to look back in time and see how cities have been impacted by the simple invention of the motor car, how cities are being impacted by the invention of the supermarket, by the shopping mall. And the way our cities currently look and operate is dramatically different to 100 years ago because of those things. What are connected and automated vehicles going to make possible for our ability to roll out our cities in ways that are fundamentally different and better than our current ones, where we can use a wider footprint for the city because we can afford to live further apart from where we work, because our vehicles will get us there without us having to spend an hour and a half consciously focusing on driving through traffic and producing nothing else of value.
Correct.
Except for grumpy, frustrated motorists.
Correct. Yeah.
And I think that's where our industry is going to be super interesting. What are urban planners going to be able to come up with once we figure out some of the first order effects? The second order effects, I don't think we can even begin to imagine, but they will be even more fascinating.
That is exactly spot on. I think really one of the thinking direction that I have in this area is like, how far can we live further from the city? And because it is the further that we live, and it's going to take much more time to commute to the city, and because of that, I think that has been sort of the build of the regional city. Like for example, in Sydney, Parramatta is considered the sub-city, where they are trying to move a lot of those offices to Parramatta so that they can share the workload, or they can share the load of the city. But still, if we were going to continue to rely on the motor vehicle or to the extent of the public transport, there is only so much we can build to be able to accommodate that. I think perhaps we need to start rethink about the build of the city. Like perhaps we need to live closer, and then have the different type of the network transport to allow us to get to where we want to get to. Like perhaps maybe scooter. Maybe it's the future. Maybe, I don't know.
Well, that's a great point. When there are other different types of transport, of micro mobility that didn't exist 3 years ago, let alone 20 years ago.
Yeah.
Who knows how that's going to change what we do with our cities? Absolutely. And as I say, I don't think anyone can imagine yet, or has imagined yet, what these are going to mean and how our cities are going to evolve from the way they currently look to the way they will look in 20 years' time, in 50 years' time. And I think it's incredibly exciting.
Wonderful. I'm gonna end this interview with one question. What is one important book that you think it has changed your worldview or changed your life?
Oh goodness, changed my worldview. I had a little bit of think about what my favourite book was, and I suspect my answer to your question would be the same as my answer to what was my favourite book. And there's lots of candidates, but I'm going to pick one amazing one, which is The Lord of the Rings.
Uh-huh.
I remember when I first read The Lord of the Rings, and I was amazed at the achievement of it, at the lyrical prose, at the fantastic story, at the amazing characters, at the unbelievable richness of imagination to come up with this world and these characters and these plots and these languages and these songs. And it still boggles my mind that one human mind came up with such an amazingly rich system. I'm a systems guy, right?
Yeah.
And I look at that system and I appreciate what every now and then an amazing human being comes along and redefines what's possible. And I think Lord of the Rings was one of those moments for me where what I thought was possible before that and what I realized was possible after that were two different things.
I think that correlates to whatever Einstein was saying, that imagination is much more important than knowledge. Yeah.
I think exactly. I think that the imagination is what defines what we can achieve, and knowledge is just what we can achieve today.
I agree. Thank you very much, Damian, and has been a great pleasure of speaking with you. I'm sure we'll chat again. Thank you very much.
Thanks, Jason. It's been lots of fun, and my pleasure.